Today, we're going inside a new kind of system that changes the game. Based on a white paper published by Anthropic, we'll explore a multi-agent AI that functions less like a single calculator and more like a dedicated research team. Welcome to our guide on deconstructing discovery. To understand the solution, we first need to understand the problem, the single-agent bottleneck. On the left, you see how a traditional AI works. It tackles a complex query sequentially, one step at a time. This is slow, but more importantly, it's fragile. If it makes a mistake on step 2, every subsequent step is compromised. This is called path dependency, and it's a critical weakness. Now, look at the right. A multi-agent system works in parallel. A lead agent acts as a director, delegating smaller tasks to a team of worker agents. They can explore different paths simultaneously, making the process faster and far more robust. The power of this system comes from its orchestrator-worker architecture, a cognitive division of labor. At the top, we have the lead agent, which acts as the strategic executive. It doesn't do the low-level work. Instead, it uses a process called extended thinking to analyze the problem, create a comprehensive plan, and delegate tasks. The lead agent then passes those tasks to the sub-agents, the parallel workers. Each sub-agent is a focused expert. It receives a specific goal and uses interleaved thinking, a cycle of acting, then reflecting on the results to efficiently complete its part of the research using tools like web search. This entire process is supported by a shared memory and a final citation agent to ensure all work is verified. So, how does this team work together to answer a query from start to finish? Let's walk through the 4 key stages. First, plan and decompose. The lead agent receives the user's request and creates a detailed strategic plan. Second, delegate and execute. The lead agent spawns multiple sub-agents, giving each a specific task from the plan. The sub-agents then work in parallel to gather information. Third, synthesize and iterate. The lead agent collects the findings from the sub-agents. If it spots any gaps or failures, it can instantly create a new plan and delegate new tasks to fill them. And finally, cite and finalize. Once the research is complete, a specialized citation agent reviews the entire report, adding sources to every claim. This ensures the final product is not only comprehensive, but also verifiable. This advanced approach yields incredible results, but it comes at a price. On one hand, the multi-agent system is over 90% more effective at producing comprehensive, accurate answers for complex research tasks. But on the other hand, it consumes around 15 times more computational resources, or tokens, than a simple chat query. This makes it a premium tool for high-value problem. But here's the most important finding. Performance isn't just about giving the AI a bigger budget. The quality of the AI model itself is the biggest lever. A smarter, more efficient agent will always outperform a less capable one, even if you give the lesser agent more resources. But with such complex outputs, how do you reliably measure success? At scale, the team uses a method called LLM as a judge, where an impartial AI scores the research reports against a detailed rubric. It's fast and consistent, but automated scoring isn't enough. Human oversight proved to be irreplaceable. Testers discovered that early agent versions would cite low-quality, SEO-optimized websites simply because they ranked high in search results. The AI judge missed this nuance. This critical human insight led to a key improvement, programming the agents to prefer authoritative sources. It's a perfect example of why the future of AI development is a partnership between human intuition and machine scale. So where is this powerful and expensive system most useful? The applications cover any domain requiring deep, multifaceted research. This includes helping developers design complex software, assisting business strategists with market analysis, optimizing professional reports and documents, and accelerating academic research. Building these systems is not without its challenges. Managing coordination between agents, preventing errors from compounding, and debugging non-deterministic systems are major engineering hurdles. But the next frontier is even more ambitious: asynchronous collaboration. The current system is synchronous. The lead agent has to wait for all sub-agents to finish before moving on. The future is an asynchronous model where agents report findings in real time, allowing the team to adapt on the fly. An early discovery by one agent could instantly change the tasks of all the others. This is the path to truly fluid, dynamic, and collaborative AI. As we've seen, the multi-agent model represents a fundamental paradigm shift. Our role changes from being an AI user to an AI director. We no longer ask an AI to perform a small task. We ask it to achieve a high-level goal. By creating a cognitive division of labor, separating strategy from execution, we unlock new capabilities for discovery. It's a powerful, resource-intensive approach that is pushing the boundaries of what's possible with artificial intelligence.